Hi! Welcome to DappBlocks. In this video, we will learn what is the Polygon MATIC and related concepts. Let's get started. Introduction. Polygon is a Layer 2 scaling solution that improves the scalability and usability of public blockchains by utilizing sidechains for off-chain computation and a decentralized network of proof-of-stake validators. It aims to enhance the existing developer community and ecosystem without compromising decentralization, and provides faster and cheaper transactions with support for all current Ethereum tools. The key features and highlights of Polygon include scalability through fast, low-cost, and secure transactions on sidechains with finality on the main chain and compatibility with Ethereum as the first Layer 1 base chain. High throughput achieved with up to 10,000 TPS on a single sidechain in internal testnet, with plans for multiple chains for horizontal scaling. Improved user experience through smooth UX and developer abstraction from the main chain to the Polygon chain, as well as support for native mobile apps and SDK with Wallet Connect. Enhanced security through stackers as chain operators in the PoS system. Public, permissionless sidechains that support multiple protocols. Proof of Stake, PoS. Proof of Stake, PoS, is a type of consensus algorithm for public blockchains that relies on validators' economic stake in the network. This is different from Proof of Work, PoW-based public blockchains, which reward participants who solve cryptographic puzzles to validate transactions and create new blocks. Examples of PoW blockchains include Bitcoin and earlier versions of Ethereum. In PoS-based public blockchains, a group of validators take turns proposing and voting on the next block, with the weight of each validator's vote determined by the size of its deposit or stake. Advantages of PoS include increased security, reduced risk of centralization, and energy efficiency. Examples of PoS blockchains include F2 and Polygon. The process of becoming a validator in a PoS blockchain typically involves holding the blockchain's base cryptocurrency, and then sending a special type of transaction to lock up a certain amount of that cryptocurrency as a deposit. The consensus algorithm that all current validators can participate in is used to create and agree to new blocks. There are many variations of PoS, including chain-based PoS and BFT-style PoS. In chain-based PoS, the algorithm randomly selects a validator during each time slot and assigns that validator the right to create a single block, with the blocks gradually converging into a single constantly growing chain. In BFT-style PoS, validators are randomly assigned the right to propose blocks, but consensus on which block is considered valid is reached through a multi-round process where validators send votes for specific blocks. In this type of PoS, blocks may still be chained together, but consensus on a block can be reached within one block and does not depend on the length or size of the chain after it. Delegator. Delegators are individuals who hold tokens but do not want or cannot run their own validator node. They contribute to the security of the network by assigning their stake to validator nodes. Delegators have a crucial role in the system as they are responsible for selecting validators. To do this, they run a delegation transaction on the staking contract on the Ethereum mainnet. Delegators' MATIC tokens are locked in the next checkpoint committed on the Ethereum mainnet. They also have the option to exit the system at any time, but they will have to wait for the unbonding period, typically around 9 days, to end before they can withdraw their stake. Fees and rewards. Delegators support the network by assigning their tokens to validators and receiving a percentage of the rewards in return. However, by sharing rewards with validators, they also share the risks. If a validator behaves incorrectly, the delegators may face penalties, called slashing, proportionate to the amount of their delegated stake. Validators determine a commission percentage to establish the percentage of rewards that will be allocated to them. Delegators can see the commission rate of each validator, which allows them to understand the reward distribution and the potential return on their stake for each validator. Validator. A validator is a network participant who locks up MATIC tokens and runs Heimdall validator and Bohr block producer nodes to assist in maintaining the network. They pledge their MATIC tokens as collateral to secure the network and earn rewards for their service. Rewards are distributed to all token holders in proportion to their stake at every checkpoint, with the exception of an additional bonus for the block proposer. The user's reward balance is updated in the contract and can be claimed at any time. However, if a validator node commits a malicious act, such as double signing, their stake may be penalized or slashed, which also affects the linked delegators at that checkpoint. Validators on the Polygon network are chosen through a regular on-chain auction process. These selected validators act as block producers and verifiers. Once a checkpoint is validated by the participants, the Ethereum mainnet is updated, and the rewards for validators are released according to their stake in the network. Polygon relies on a group of validators to secure the network. Their responsibilities include running a full node, producing blocks, validating and participating in consensus, and committing checkpoints on the Ethereum mainnet. To become a validator, individuals must pledge their MATIC tokens using staking management contracts on the Ethereum mainnet. Polygon PoS Architecture. The Polygon network is a blockchain application platform that offers a combination of proof-of-stake and plasma-enabled sidechains. It features an elegant architectural design that separates the generic validation layer from various execution environments such as full-blown EVM sidechains and other Layer 2 methods such as zero-knowledge rollups. To implement the PoS mechanism on the platform, staking management contracts are deployed on Ethereum, and a group of incentivized validators run Heimdall and Bohr nodes. Ethereum is the first base chain that Polygon supports, but the platform plans to offer support for additional base chains, based on community input and consensus, to create an interoperable decentralized Layer 2 blockchain platform. Polygon PoS has a three-layer architecture. Staking smart contracts on Ethereum. Heimdall, proof-of-stake layer. Bohr, block producer layer. Polygon smart contracts on Ethereum. Polygon maintains a set of smart contracts on Ethereum, which handle the following: staking management for the proof-of-stake layer. Delegation management including validator shares. Checkpoints/snapshots of sidechain state. Heimdall, proof-of-stake validator layer. Heimdall is the proof-of-stake validator node that works in conjunction with the staking contracts on Ethereum to enable the PoS mechanism on the Polygon network. It is built on top of the Tendermint consensus engine, with modifications to the signature scheme and data structures. Heimdall is responsible for block validation, selecting the block producer committee, checkpointing a representation of sidechain blocks to Ethereum, and various other tasks. The Heimdall layer aggregates blocks produced by the Bohr layer into a Merkle tree and periodically publishes the Merkle root to the root chain. These periodic publications are called checkpoints. For every few blocks on Bohr, a validator, on the Heimdall layer, validates all the blocks since the last checkpoint, creates a Merkle tree of the block hashes, and publishes the Merkle root to the main chain. Checkpoints are crucial for two reasons. They provide finality on the root chain. They provide proof of burn in the withdrawal of assets. In summary, a subset of active validators from the pool are selected to act as block producers for a period, with the selection being agreed upon by at least 2/3 of the validators. These block producers create blocks and broadcast them to the rest of the network. A checkpoint is made up of the root of all blocks created during a given interval, which all nodes validate and add their signature to. A selected proposer from the validator set collects all signatures for a particular checkpoint and commits it to the main chain. The responsibility of creating blocks and proposing checkpoints is dependent on a validator stake ratio in the overall pool. Bohr, block producer layer. Bohr is the block producer layer of the Polygon network, responsible for assembling transactions into blocks. The block producers are periodically rotated through a process called committee selection on the Heimdall layer, in intervals known as spans on Polygon. Blocks are generated at the Bohr node and the sidechain VM is EVM compatible. The blocks created on Bohr are also regularly validated by Heimdall nodes, and a checkpoint that includes the Merkle tree hash of a set of blocks on Bohr is committed to Ethereum periodically. Thank you for watching. Please hit the like button and consider subscribing to our channel. Turn on notifications so you never miss an update. We appreciate your support and look forward to bringing you more content in the future. Thanks again, and see you in the next video.